Welcome back, everyone, to the eCoreAcademy e-learning platform today. My name is AJay Raj, back with yet another geometry video. And today's lesson topic is all about kites and trapezoids. Before we jump into the meat of today's lesson, please make sure you do four things. Please make sure to smash the subscribe button down below, hit that like button on this video, turn on post notifications so you don't miss out on any of our channel's latest uploads at eCoreAcademy, and also feel free to drop a comment down below in the comment section. Of course, your feedback and your criticism will not go unnoticed, and we'll try and implement it in our future videos. So the whole theme and purpose of today's lesson is to take a look at the properties of kites and the properties of the different types of trapezoids. Now, I've done an opening video on the different types of quadrilaterals. I even did rhombuses, parallelograms, rectangles, squares, and I even went into depth with trapezoids. However, I went into depth with the specific properties of generic trapezoids. However, we didn't get into the specific types of trapezoids. So you're expected to already know the basic properties of trapezoids, but if you aren't coming into this video, please make sure to visit that video on trapezoids. I will link it in the description down below for your reference. So please make sure you have watched that one or you already have previous knowledge on trapezoids as a general shape and their general definition as a quadrilateral before watching and tuning into this video. And of course, we have another entirely new figure that I have not mentioned yet or we haven't looked over yet in this course, geometry course. We have our kites. So kites are a different, unique type of quadrilateral. You have your different classifications of quadrilaterals, and I will explain that later on in this video. So buckle up, stay tuned, and let's dive right into it. So let's start off with our kites. These are new figures that I really want to introduce to you guys. So this is all about our introduction to kites. So what exactly is a kite? A kite is a quadrilateral that has two pairs of congruent sides that are adjacent. That's the only definition for a kite. Now, a kite can have many different properties and different representations, but a kite is considered separate from any type of parallelogram and also separate from any type of trapezoid. So when we have our entire quadrilateral family tree, we see that we have our quadrilateral as the mother, basically, of the entire classification of four-sided figures. So technically, a kite has to be a quadrilateral in this case because it does have two pairs of sides. So that's four sides. But then within that quadrilateral, we have three different classes. We have your trapezoids, parallelograms, and then your kites. When it comes to your trapezoids, you have three different types of trapezoids, which we'll get into today. Kites, they all have regular types of kites, so they're all going to look similar. They're all going to be similar figures in some manner. And then when it comes to parallelograms, you have much more diversity because you have general parallelograms, you have distinguished parallelograms, and then of course you have things like rectangles, squares, rhombuses, all that sweet stuff you have within parallelograms. So kites are a very unique figure, but they're not as popular. However, of course, in geometry, we have to look at all of these shapes, and yes, they will have some sort of utilization later on, and this is a very popular shape for higher level math courses and competitions as well. So a kite, like I said, has two pairs of congruent sides that are adjacent. I'll show you that in a picture, what exactly adjacent means. We're calling from our basic geometric terms and definitions at the beginning of this course. So a kite also has perpendicular but not congruent diagonals, as it is classified as its own type of quadrilateral, just like a trapezoid. So we have our trapezoids, your kites, and then of course your parallelograms. So it has perpendicular diagonals, just as a diagonal must be perpendicular. However, this is another difference between parallelograms and basically your regular trapezoids, is the fact that the diagonals are not going to be congruent. Instead, they are going to be much different in length. However, they do intersect at a 90-degree angle. Therefore, they are perpendicular. So this is an example of a kite. So if you think of the word kite, you might have thought of something completely different. No, it's exactly what you see in real life. Those things that, you have the little handle, the spindle there, and then you're tying around that little knot. Could be string, could be yarn, anything that you have, rope, and then you're connecting it up to the kite that you're actually flying high in the sky. So it's the same exact type of figure there. And then, of course, this is our geometric breakdown of that figure. If we take a look here, we have some of the properties. So what I mean by adjacent congruent sides is adjacent mean that they share a common vertex, meaning they're directly touching. So these two, EK, line EK, or side EK, and ET, they both touch at the point E because they have that letter E in common. Therefore, these two sides must be congruent in length. And then same thing with KI and IT. They both make the same contact at I, and therefore they have that common letter shared amongst both line signatures. So they both have the common point of I. Therefore, they are congruent. pairs, as you can see with those congruence lines. And then, of course, you can see the diagonals KT and EI, and then they intersect at point S. When they do intersect, they're forming a 90-degree angle. However, as you can see, they are far from congruent. They are very, very irregular in shape in comparison to each other, so no similarity in that. Sorry, no congruence in that. There is similarity in that, but no congruence in that. Now let's introduce our trapezoids. So let's look into the specifics of what the types of trapezoids are while we introduce them. And of course, just review exactly what are some of the basic properties of trapezoids that differentiate them as specified quadrilaterals. So trapezoids are their own classification of quadrilaterals, as they have only one pair of parallel sides, as there are three different types of trapezoids. So not only do we have our general trapezoid that has its basic qualification of having only one pair of parallel sides, that's consistent amongst all the types of trapezoids. However, we have three different breakdowns of trapezoids into their own classification. So that's your classification. Just as a parallelogram is broken down into distinguished figures such as rectangles, squares, and rhombuses, we have trapezoids being broken down into three different types of classified trapezoids, of course. And of course, they're going to look a lot more irregular than your average shape. However, they do contain the same property in the fact that they have one pair of parallel sides, unlike kites, which do not have any of those properties, making it a drastically and distinguishable figure as a quadrilateral. So these are the three different types. We have a right trapezoid, an isosceles trapezoid, and a scalene trapezoid, but you're most familiar with this regular trapezoid right here. And I will show you what your regular trapezoid is out of these three. Which one of these will be our regular trapezoid, and I'll show you that. And you probably will have that major realization that this isn't the only type of trapezoid. No, we're all consistent to thinking that this must be your only type of trapezoid, where your top base is parallel to your bottom base. So this is going to be parallel to your bottom base here. So let's say B1 is parallel to B2, and that your legs here, your legs have to be congruent. L1 is congruent to L2, but that's not necessarily true. That there's only one value and one factor here that must be true, and that's the parallel lines. And these top and bottom bases don't necessarily have to be the parallel lines. You can have the legs as being parallel bases, and you can have a rotation of this figure, and yet it's still a trapezoid. That's still going to maintain its own properties, and there's many different circumstances, and there's three specific ones that we're going to go over now. Of course, specific circumstances other than this will always fall under one of these three categories. But for now, let's take a look at kites, and let's dissect what exactly the properties of kites are, and then let's move into the three different types of trapezoids. So this is all about kites. Kites part 1, properties of a kite. So the sum of all the interior angles of a kite, like any other quadrilateral, is 360 degrees. So all the interior angles, all four interior angles will add up to 360 degrees. However, there's specific properties between angle relationships within the given kite. And kites also have two pairs of congruent sides that are directly connected to each other. That should be connected to each other, which means that they only have one pair of opposite angles that are congruent. So they have two pairs of congruent sides, and only one pair of opposite angles will be congruent. And I'll show you which ones those are. So the perpendicular diagonals also bisect two of the interior angles of a kite. What that means is each perpendicular diagonal will actually intersect each of the angles as known, but it's also going to bisect only one pair of those congruent angles. So those congruent angles that we have are also going to be bisected. So I'll show you what that is. So if we take a look at the angles K and T, these angles are the smaller side angles of this smaller diagonal. K and T are going to be congruent to each other. So K is congruent to T. However, E is not congruent to I. That's just the general consensus that we come from. So E is not congruent to I. So only one pair of opposite angles will be congruent. So that's K and T. K and T. And then another thing about that is the fact that we have our given diagonal of the smaller diagonal as shown, KT, is actually going to bisect the angles of KT. So whatever the congruent angles are, they're also going to be bisected by your given they're not going to be bisected by your given congruent angles. Instead, the opposite angles are going to be. So I'll explain what that means. So if we're taking a look here at our congruent angles here, we see that we have angle K and angle T. Angle K and angle T as is are always going to be congruent to each other. However, we know that diagonals also have a tendency to basically take apart your given angle. It's going to split it into two different angles. However, it does not bisect the angle. So your diagonal KT will not bisect K. So it will not split K into two equal parts. They will not be congruent. And same thing goes with T. So there'll be two different measures. However, when it comes to angles E and I, the angles that are not congruent to each other, that are opposite angles, they're going to bisect it. So your longer diagonal is going to bisect the opposite ended non-congruent angle. So E and I are going to be bisected. So E is going to be bisected, and I will also be bisected by the same line EI, that diagonal. Now for kites part 2, let's look at area and perimeter properties of kites. So the perimeter of any given figure can be a quadrilateral, a polygon of any sorts. You're going to have a sum of all four side lengths specifically for a quadrilateral, but for any given polygon, that's going to be the sum of all sides. It can be irregular or regular. For a quadrilateral, it's a sum of all four sides. In this case, when it comes to your kite, it's going to be the twice of each congruent side. So we know that we have two pairs of congruent sides. So we know what each distinguished side length is. So we know what the short side is and what the long side is. We can just merely multiply each value by 2 and add them together because we have those given congruent pairs. And for area, we're going to calculate using four triangles made up by the diagonals. I'm going to explain exactly what we're going to do here. It's just like a rhombus property, except that we have to take another step and be given more information in this process. So if we have, just simple practice, we have 12. If we have 12 here and our 4 here, this is going to be in inches. Let's put inches. Keep our units there. What is the perimeter of this figure? Well, we know one side. We know this long side. That's also going to account for this side here. So it's also going to be 12 inches. So it's going to be 12 times 2 equals 24 inches. And then, of course, we have our 4 inches here. We also know that this guy is going to be 4 inches. So we're going to do 4 times 2. We're going to get 8, and we're going to add these together. So 8 plus 24 equals 32 inches in area. All right, so that's our basic, perimeter calculation here. But let's get into depth with what our area will actually be. What exactly will our area look like, and how can we calculate it on such an irregular figure that does not have a defined, consistent difference in distribution? So unlike those smooth calculations with parallelograms and squares, rectangles, and even trapezoids, so they have more of a consistency. So with kites, what you have to do is you're going to have to utilize the diagonals. So as you can see here, the two diagonals have been drawn within the given kite. And we're going to utilize the 4 different right triangles that are going to be created. Remember, when diagonals intersect, they make a right angle. And when one right angle is made, all 4 right angles of this intersection are going to be right angles because it's going to be 360 degrees divided by 90, and that's 4. So all 4 are going to be 90 degrees. So we can just draw this here, one giant square to represent all 90-degree angles of these 4 different right triangles. Now, one thing that we do know is since these two sides are going to be congruent to each other and that this diagonal is going to be consistent and bisected, we know that these two triangles, so this guy right here, is going to be congruent to this guy, and then these guys are going to be congruent to each other as well. So what we merely have to do is calculate what the given area of each given, each triangle is, multiply each one by 2, and then add them together. So we're going to utilize those same properties, 12 inches and 4 inches, and I'm going to give you some more information this time because we need to get that base of our triangle and of course the height of the triangle. So in regular terms, you technically would not be given these 12 inches and these 4 inches as side lengths. Instead, you would be given merely the interior terms. So I'm going to make these the interior terms this time. So we have our 12 inches here. Let's make this our 12 inches, this diagonal part here going from here to here. And then we're going to make this part of our diagonal 4 inches. And this part of our diagonal 4 inches. So when we do that, we can easily calculate what our area is going to be. So we can multiply 4 by 4, we get 16. And then, of course, 16 divided by 2 is going to be 8, so 8 inches squared. And then over here, we have 12 times 4. 12 times 4 is 48. 48 over 2 is 24 inches squared. We're going to multiply 24 by 2. 48 inches squared. And then, of course, we're going to multiply our 8 by 2, of course, because we're going to have to compensate for that other triangle here. So 8 times 2 equals 16 inches squared. We're going to add those together. Let me get 54. Oops, I apologize. 64. 64 inches squared. All right, so that's the area of this entire kite. And sometimes you're going to be given situations where you're only given the base or the height and merely the hypotenuse of the given triangles. And then, of course, you use your Pythagorean theorem like I did with my rhombus problem. Didn't want to take away from that. So, of course, if you're curious on how to do that, refer back to my extended problems with parallelograms part 2 video, or part 1 video, sorry, when I go where I go through that similar type of problem. Now let's breeze through the different types of trapezoids just to get you guys acquainted. I've already gone through all the properties of regular trapezoids, calculating area, perimeter, and diagonal properties. So let's just go through and sift through these simple types of trapezoids. So the first type of trapezoid that we have is our right trapezoid. And a right trapezoid is a trapezoid with two congruent right angles. So what are some properties that it's going to have? It's going to have two parallel sides, but it's also going to have two congruent right angles. And you can have a right isosceles trapezoid and a right scalene trapezoid. So what exactly does that mean? I don't want to take away too much, but I will explain exactly what that means in terms of a right trapezoid. So in this case here, we're going to have at least two right angles in this trapezoid as shown here. And it's kind of like a square and a triangle almost being formed here. You kind of split this figure up. So this could also be considered a complex figure. However, we can just use the regular area or trapezoid formula, base 1 plus base 2 over 2 multiplied by the height, and the height is already smoothly given here by a side length here. And all you need to calculate is the average of your bases, and they are both going to be parallel as shown. This top base and this bottom base are going to be parallel to each other. So you can also have a right isosceles trapezoid, which is going to be isosceles, meaning it has two congruent sides. As you can see here, these sides could possibly be congruent if it's a right isosceles, or you can have a right scalene in which none of the sides are going to be congruent to each other. All of them are going to be different lengths, as shown. Trapezoids part 2, let's take a look at isosceles trapezoids now. So an isosceles trapezoid is a trapezoid with two congruent legs. Like I said, you're going to have two congruent legs in this term, and that's going to be what your regular trapezoid is going to look like. So isosceles trapezoids are derived from the half parallelogram theory and are considered proper trapezoids. So remember, like I said, where do we get this whole concept of proper trapezoids? We started off by looking at what parallelograms were. Generally, that's what you look through in your geometry course. I decided to do trapezoids first, get any confusions out of the way when I did my parallelograms sequences of videos. However, when it comes to your trapezoids, trapezoids are derived as half of a parallelogram. So let me just draw that out for you here. So let's take a look at one parallelogram as shown. This is what our parallelogram looks like. What happens if we split this guy in half? We split this guy entirely in half, like just a line right through the middle. We're going to form two congruent trapezoids as shown. But of course, one's going to be upside down than the other one. So they're going to be two congruent trapezoids. This guy right here, because it's coming from this parallelogram, it's going to have equal legs. These legs are going to be equal length, and then the bases are going to be parallel to each other because they took that same property away from the parallelogram. And that's the same exact thing that comes with an isosceles trapezoid. You're going to have congruent legs right here. Congruent legs, of course. You're going to have your parallel bases. You're also going to have equal diagonals as well. And that's why it's taking the same exact properties as your parallelogram, and it's considered a proper trapezoid. That's how the whole theory for the averaging of the bases was come around for the area. But it works for every single type of trapezoid, not just isosceles and proper trapezoids. So I'm going to write here /proper, just for your reference. And finally, we have our trapezoids part 3, and this is our scalene trapezoid. So a scalene trapezoid is a trapezoid without any congruent angles or side lengths. So it cannot have that common angles alike, just like isosceles and right trapezoids would have. They would have minimum two congruent angles. So the only property that makes a scalene trapezoid a trapezoid is the fact that it has one pair of parallel sides, and that's the only thing that you need. You only have that one property that classifies it as a scalene trapezoid. So that's the only property of it, of course, and that's the only property needed. So only property and only needed one. Only one necessary. And as you can see here, all of these side lengths are going to be of different lengths. And same thing goes with the angles. So this guy is going to be 1, 2, 3, and of course our 4. They're going to be all of different length and different measure. Therefore, it's a scalene trapezoid with only two given congruent bases. Two given parallel bases. We always consider the bases parallel, and of course the other two remaining legs are always going to be your legs, and the legs can never be parallel. All right, everyone, so that'll be it for today's video. I hope you guys enjoyed. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below. Drop a comment down below as well, and feel free to click that post notification bell so that you don't miss out on any of our channel's latest uploads. We're going to be uploading every other day and every 3 days at minimum. We're also going to be cultivating our Meet the Champ section as well, so stay tuned for the eCore Beyond the Books and the Meet the Champ section, and also some pretty new faces when it comes to our different courses that are going to be coming about. With our different math courses and our STEM courses, we're also going to be expanding beyond that, and you'll see new faces and new courses. So please, I hope you guys are excited as we are, and please feel free to check them out. Also, feel free to check out our website at www.ecoreacademy.org. We put a lot of effort into curating that. It's an entire website, full unlocked access to what we as an e-learning platform actually offer to you guys. So we have unlocked full access to quizzes, worksheets, note sheets, that go along with each and every single one of our videos, organized into separate lesson studies. There's many other added features on the website to help you prepare and basically go through this entire course as if it were to replace your school and also help you with school as well. Feel free to email us at eCoreAcademy@gmail.com if you have any questions, and check out all of our socials in the description box down below at Facebook, Twitter, and Instagram. See what kind of interesting content we have out there, and use our mediums to share all of our videos. Once again, everyone, I hope you guys enjoyed this video. This has been AJ, and I'll see you guys in the next one. Peace.